All right. So this week we've been talking about a couple different things. On Monday we talked about finding the area of triangles using our area of a triangle equals 1/2 times the base times the sine of our angle times the other side line. So that was when if you didn't have that height, we could solve for it as long as we knew the other side and the angle using our sine function. Yesterday we talked about Cavalier's principle and basically finding the volume of oblique shapes. So those were our slanted shapes using our, or we're talking about, we noticed that the Cavalier's principle basically said that the volume of those oblique shapes is the same as the normal shapes. All you needed was the area of the base and your height, and you would find the volume just like any other prism here. So we're going to do a quick review over those two things today, and then we're going to talk about density. So density, once again, it's going to be that third final piece we'll have to talk about for this Friday assessment. And then we'll review on Thursday, a bit of Friday, and that will be our final assessment for our class. Exciting. So looking at this period or this prism, we want to using Cavalier's prism or principle, we want to find the volume of this oblique triangular prism. What are some things you notice?
They don't give you the height.
Right. So they don't give us the height of our prism. So we know volume of a prism is area of the base times the height. We don't have that height, so that's something we'll have to solve for at some point. What else do you notice? What are some things that you would try to do to start solving?
We have 5 instruments.
What was that? For the height?
First, find your base.
Is that what we're talking
Right.
about? So we have 10, we have 26. So we can do Pythagorean theorem to find that height. Is that what you're talking about?
Yeah.
Okay. So if we were solving for our height, we have this right triangle here. We have one leg of 10. We have our lateral edge of our prism to be 26. So we can solve for that vertical height using a squared plus b squared equals c squared. That's 10 squared plus h squared, which we don't know, is equals 26 squared. That's 100 plus h squared equals 26 squared is 676. And then we can subtract 100, and we get h squared to equal 576. One step, of course, square root, and we should get our height, which is 24. Okay, so we know the height, we know that piece.
Now you can solve for your base.
Now we have to find the base. Okay.
And then just 17 times 26.
So that would be the area of this like back side.
What is the base?
Or sorry, that would be the area like this front side. So your base is going to be this little triangle. So we have this triangle on top
Oh,
of
the
it.
triangle? Why wouldn't it be the rectangle on the bottom?
I mean, it could, but because it's a triangular prism, our bases of our prism are typically going to be the two shapes that reoccur on the top and bottom, or on the two ends of your shape. Those are what you consider bases. You could find, and sort of if you were to slice into this, that's the shape that's going to reappear. Or if you look at the cross section, and so whatever we think that cross section looks like, that's essentially what your base is. So we have this triangle on the bottom down here that we need to find the area of. How do we find the area of the triangle?
1/2 times base.
1/2 times base times height. Do we have the height of our triangle though? So on Monday, we said if we don't have the height of the triangle, we can get it using sine of our angle and then the other side. So this was that formula we used on Monday to find the area of triangles. So it was 1/2 times our base, and then the height was represented by the sine of whatever that angle is times the other side. We just had to put that straight into the calculator. So it was 1/2 times our base of our triangle, which could be just any of the sides, is 17, times the sine of our angle, which I believe is 37, times sine A is 15. So we multiply all that together, now we just our base of our triangle, which should be 76.73.
I don't know if it was.
Yeah, it just doesn't show up that way. And so 76.73 times our height will give us our total. So our final volume should be like 1,841. And so this was sort of a problem that incorporated both the things we talked about today, or both the things we talked about. Incorporated Cavalieri's principle, incorporated using that formula. And so if you're good with both of those, questions over any of this? So today we're going to talk about density. What is density? So when I say the word density, what do you think of?
Heavy.
Okay, heavy.
All of it.
How tightly packed something is. Okay.
I think of a very thick croissant.
Whoa, Val. What was that? Mass over volume. Density equals mass over volume. Got it.
Formula just comes from.
Yep. Okay. So in physical science, you probably talk about density being mass over volume. When we talk about density and mass, we're going to change it just a little bit to sort of incorporate other situations that we can talk about density, so like population density or density of other types of objects, not just necessarily density of like something with a mass or volume. But you can talk about a density of something over an area or over distance. But that is good. Density equals mass over volume. So when you talk about density or area density in a sense, typically density is talked about as the quantity of something per unit, or per unit of measure. So that unit of measure could be a distance, it could be an area, it could be a volume. So it could be how many inchworms are there on this stretch of mile? How many people live in this square area? How many ants do I have flying around in this volume of the space? Those are random situations, but it's always the quantity of something divided by the amount of space that it's inhabiting or taking up. So density is the number, essentially the number of things in the quantity divided by its amount of space. Like an example is population density, which is the number of people divided by a certain amount of land that they take. So if we were to calculate Ridgemont's population density, or Mount Victory and Ridgeway's population density, like this whole little area, we're going to get a low population density because there's a lot of empty land for like farm fields and things like that that people aren't living in. And so you have a small population in a larger area, so you're going to get a low population density because there's less people taking up a larger amount of land. But also we use the formula like Alex said, density equals mass over volume, which is something we'll use. So sometimes you might be given the density and you might need to solve for the mass, you might need to solve for the volume, depending on that, or sometimes you might be given the mass or volume and you might need to solve for the density. So we'll use that formula a little bit as well. So we're just going to look through a couple examples of the types of problems that involve density. Some of them will be a little bit easier, some of them we might have to solve for a couple different things. Sometimes we might have to find the volume or find the area to use it, other times it'll be given to us. So as of 2015, the most densely populated state in the U.S. was New Jersey. The 2015 population of New Jersey was 8,957,907 people, and the size of the state was 7,354 square miles. So it's the smallest state, but it's pretty packed. So we want to figure out what is the population density of the New Jersey to the nearest square mile. So how many people are living in each square mile? Roughly each square mile of New Jersey. And so, like we just were talking about, density, once again, it's sort of like the amount or the number of something divided by the amount of area or space it takes up. And so, our amount of people, our population of New Jersey, is the 8,957,000. So 8,957,907. That's our population in New Jersey. We're going to divide that by our 7,354 square miles. And so that would be our population divided by the square area, and that will tell us how many people are in each square area, which is 1,218.1 people per square mile. And so 1,118 people per mile, New Jersey, which is crazy to think about because that's a lot of people in a mile. You like find a square mile in Ridgeway and put a count on computer like 7. Yeah, you probably put the population in a square mile. Yeah, I would believe it. So the population density in this place is just much more larger just because there's so many more people in such a small area. Yes, because that is part of like the area. So yeah. So something to pay attention to is just your units. So in this case, we're doing people per square mile. So it's always going to be something divided by something. So whatever is ever in the numerator, whatever that amount is, that's going to be the first part of your unit, and then divided by whatever. So it might be an area, it might be a volume, it might be a single distance, but that should always be brought. And so if it's an area, it's going to be squared. If it's a volume, it's going to be cubed. If it's a distance, it's just going to be normal. So we always want to watch the units we use as well, because that's important. Because 12,018.1 people per square mile is different from 12,018 people per mile, or miles cubed, or feet cubed, or something like that. So,
I want to see what it is 2011.
what?
2011, 2015.
Yeah, 2015.
I
So
want to see if it's 2000.
what it was like now, that'd be crazy. See if it increased. All right, so similar idea for this question. A rectangular chicken coop has sides lengths of 9 feet by 5 feet, and there's 21 chickens in this coop. So what is the population density of chicken per square foot? Sorry, so I can't read that. What are your thoughts when you see this question?
There's 3.
Okay.
Two steps. Yeah, that's rectangular chicken coop, so.
We're going to need to find the area of it.
Wouldn't it just be 45?
5 as one side, 9 as the other. So 45 would be the area of the rectangle. Okay.
So, then you just do 21 over 45.
Density is just going to be our number of chickens we have, which is 21, over the amount of area that they actually do, which is 45. If there's 21 over 45, it's 24, 6, 7 chicken per feet square. Roughly half a chicken per square foot, so every chicken gets roughly 2 feet, I guess, of room. I don't know if that's a lot for a chicken or not a lot for a chicken, but that's what they have access to. So, once again, it's just really finding how many of the thing you have, dividing it by that area or the volume or whatever you need. Sometimes you might need to calculate like you did on this one. Other than that, that's okay. And then our units is chickens per square feet. Easy enough, simple enough. So a kitchen was remodeled and a granite countertops were installed. A rectangular island in the kitchen now has a granite top measuring 5 feet by 8 feet by 12 inches, or 1.2 inches. The density of the granite is 168 pounds per feet cubed. So we want to figure out how much does the granite top on the island weigh.
So this one's backwards.
So we're not necessarily looking for the density this time. We're looking for the weight or mass. The weight necessarily isn't the same as mass. Don't necessarily touch their weight is created from mass, but essentially we're solving for the mass. We're looking for mass. So we know density is mass over volume. So what information do we have?
Density.
We have the density, so we have that 168. We know we're looking for the mass. We need the
There's a
volume.
million measurements. There's
Right. So what is this granite countertop look
rectangle. It's a rectangle.
like? Okay. So it's a 5 foot by 8 foot.
And then 1.2 inches.
Okay. Very thin granite countertop. Now here's the thing though.
Does that even matter?
This is what matters.
The thickness.
So because we need a volume, we're going to need a third dimension. So we will need to know how thin it is as well, or how thick it is, along with the angle. Because so rather than doing mass over area, we do mass over volume. So the thing is, what do you notice about your measurements with your 8 feet and your 5 feet and your 1.2 inches? Okay.
Well, they're 2 feet and then 1 inch.
So we're going to have to turn that into feet. We need all those units to be the same, or all those measurements to be the same. So how can we turn that into feet?
Can't we just turn feet into this?
We could. And then our density would also have to be converted as well. So that's going to be more conversion.
Can you do that on the computer? It's 12 in like the inches I want to do, and we just be like 0.12 feet. If you convert it and then convert it back, would that be?
So we know there's 12 inches in a foot, right? So if we take 1.2 and divide it by 12, that's how many feet we have. So 1.2 divided by 12 is 0.1 feet. So that's going to be our width we have right here. And so for our volume, how can we calculate the volume?
Where do you find the area of the base?
Well, if your area of base is just this front slab or the top slab, which is 5 times 8, and then times your height, which is just 0.1. So the volume should be 4 feet. 5 times 8 is 40 times 0.1, which is. We have the volume, we have the density, we can solve for the mass. How can we get that mass? Okay, you just multiply our volume over. And so mass equals 4 times density, which if we multiply that should give us 672 pounds. That is a heavy slab of granite, or a very massive slab of granite. Don't take it for granted.
Wow.
So once again, sometimes we might have to solve for different things. So sometimes you might be given the density, we need to use that, our knowledge of what density is, to solve for the other missing pieces or find out the piece. Sometimes once again we might have to calculate that volume, things like that. But we know how to calculate volume. We've been doing that for weeks, so that's such a probably easy to do. Any concerns over this question?
All right.
Most of the time, you won't have to do anything first, by the way. Most of that should be good for you. All right, we're going to do one more question together, and I'm going to give you a question to try. So in the movie Raiders of the Lost Ark, The archaeologist Indiana Jones has to replace a solid golden idol with a bag of sand, and the idol is resting on a platform which precisely counterbalances the temple's ancient self-destruct mechanism. So there's that scene where he's like in the temple and he has like the bag of sand, he has to like switch it very carefully, and but then like the boulder comes. If you haven't seen Raiders of the Lost Ark, you know that scene. Okay. So the idol can be modeled by a cylinder with a height of 18 centimeters and a radius of 6 centimeters. So the density of gold is 19.32, and the density of sand is 1.6 grams per centimeter cubed. So we need to find two things. We want to find the weight of the idol, or the mass of the idol, in kilograms. In kilograms, that means grams. And then we want to find the volume of the sand that is needed to replace the idol. So, we have a bit of information. Helping Indiana Jones. How can we go about finding the mass of this? Okay, so we know density equals mass over volume. We know we have this little idol. It's roughly cylindrical shape. And our height of our idol, I think we were told, was 18. Our radius of our idol is 6. See that? Our idol. So what are some things we need to know? What are some things we need to find?
The volume of that?
Okay, so we'll have to find the volume of that.
Area.
So, we think volume of a cylinder is area of the base times height, but area of a circle is just pi r squared. So pi r squared times height essentially is the whole volume. That's a formula we've used before. So our radius we are told is 6, and then our height is 18. So if we multiply all that together, that will give us our volume of our little idol, which we end up to be 2,035.75. And that would be centimeters cubed is our volume. That's going to be our V, or bottom part. We're still solving for mass, so we need to know that density. Do you know the density for the idol? Right, so the density of gold.
Idol, same thing.
Yeah, it's a gold idol, so it's going to be the 19. 19.32 equals our mass over our volume of 2,035.75. We need to solve for that.
Multiplied.
We just multiply by 2,035.75. And that'll cancel out. We do the same with this side. And we get our mass to equal 39,330.69 grams. What do you think about it? These are grams, so grams are really small, or grams are really light. So if you convert that to kilograms, it's like roughly 4 kilograms. And then if you think about that in like pounds, something like that. That'd be roughly 40 kilograms. Sorry, 40 kilograms, which is like 80 pounds. That's a heavy idol. Heavy little idol.
I mean, it's old, so.
Yeah. So that's our mass. So that was part A. We want to find the mass of the idol. So the other thing we need to know is what is the needed volume of sand to avoid tripping the self-destruct mechanism. So as soon as you take the idol off, the pressure plate goes, and then the boulder starts rolling down, and the temple starts collapsing and all that. So you have to put the sand on there to keep the pressure plate from going off. So we need to figure out how much sand do we need. So thinking through, what do we know?
the density of the sand.
Okay, so we have the density of sand to be 1.6. So we have density over volume. So 1.6 equals our mass over volume. We're looking for the volume, so we need to know this. What's our mass rate? It's going to be the exact same answer as what we got up here, because in order for them to be, for work for the counterbalance thing, in order for you not to set off the trap, it needs to be the same. So we're going to just replace our 39,000 with our mass. .69 all over our volume. We need to solve for that volume. What can we do? So mass, well, if we multiply by the mass or the density, they're not canceling out.
Okay, what if you multiply?
Can you multiply variable?
So do like times called b, so times b, and then do that to that side, so it'll be like 1.6 b, and then equal action thing, and then you can divide it.
And our answer comes out to be a large number. B is 24,581 point something 68 centimeters cubed. So going back to this, multiplying by b over. If I put this over 1, it's the same thing as proximal point. So if you ever have a fraction on one side and just a single digit, you can always put over 1 and multiply if that seems easier to you. But multiplying that variable over and then dividing by that is exactly the same steps as you're doing in proximal point. 24,581. Our initial volume of our idle was 2,335. So our idle's like this big, and then we're replacing it with a 20. This is basically 10 times larger or 12 times larger than our idle. So that's big bag sand. So maybe the movie isn't as accurate as it seems, but it's Indiana Jones and Raiders of the Lost Ark, so I don't know everything about it. Whatever. I thought that was a fun question. So we feel okay with density so far, solving for the different pieces, solving for the volumes of different things.
Kind of hard.
So I'm going to give you one problem to try to practice on your own, try to work through, see if you can find the answer of, and that will be a little sort of board. Do it again. You just.
Process.
Okay. So 98 cut boulders are being brought to help prevent further erosion in a portion of the coastline. Each boulder has been roughly cut into a cube with side length of 0.8 meters. The stone in the boulders have an average density of 3,000 kilograms per meter. So we want to find the average mass of each of the boulders in kilograms, and then find what is the total mass of all the boulders combined. So there's two things. First, find the mass of a single boulder, and then you just need to find the total mass.
What do these boulders look like? Like what shape?
What were you told? So each boulder is roughly cut into a cube.
So
It's roughly cut into a cube. So we'll use that, our knowledge of a cube to help us find performance. Once again, we need density equals mass.
we've never used cubes. Wait, isn't it just a square?
A square with a square on the side.
What's that?
Alright, so take a moment, see if you can work through this, see if you can find the missing pieces that you need. Let me know if you need some assistance. Okay, density equals mass volume. Our density we were told was 3,000. equals our mass, what we solve for, over our volume of our cube. So we think about a cube is a prism, like all of our square sides, like that. We know all those sides are 0.8, so our area of our base would be 0.8 times 0.8 would be the area of the square at the bottom, times another 0.8 would be the height, where this is the same as 0.8 to the third, also known as 0.8 cubed, but it's why we call it cubed. And so that should give us 0.512, which is going to be our volume that we from the bottom. In order to solve, you can either put this over 1 and cross multiply, or just multiply 0.5 over. And that should give us our mass of 1,536. And that would give us for each single boulder. And all we have to do is take that, multiply it by 98 to get the total mass of all the boulders combined to get 98. You okay? Tomorrow we'll practice density, Cavalier's principle, using the triangle. So we'll practice all that different stuff we talked about. So it'll be a little bit of a hodgepodge of a lot of different things. You'll be given your formulas, stuff like that. And then we'll take care of ourselves.